Hello guys, this time I will go over this question number 13, 14 and whatever. And 13 is pretty easy, that's a L'Hopital's rule. So what's gonna happen is you have a limit and you're gonna plug in, whenever you see limit, first reaction that you have to do is you just plug in the number and see what happens. Okay, so you plug it in, sine, so you get sine of 0. And this one is gonna be e to the 0 minus 1. And as you can see, sine of 0 is equal to 0. E to the 0 becomes 1. 1 minus 1 is equal to 0. So you become 0 over 0, right? You cannot have this. So that's a L'Hopital's rule. So you're going to do L'Hopital's rule, which means you're going to do, so this, what you're going to do is limit x approaching to 0. You drive sine x. So derivative of top is going to be cosine of x. Your derivative of bottom is going to be e to the x, because minus 1 will disappear. Now let's plug in. So if you plug in 0 to cosine x, that is going to become 1. If you plug in 0 to e to the x, that's going to be e to the 0, which is 1. So it's going to be 1 over 1, which is 1. If you still get 0 over 0, you do L'Hopital's rule one more time, like drive one more time from top and bottom. So your answer for this one is going to be 1. Now let's do question number 14. You have to read it carefully, I believe. The particle moves along straight line so that t is greater or equal to 0. So that's acceleration at time t equal to 0. Now, velocity of the particle is equal to 2 when t is equal to 0. So basically, this 2 is going to be considered as c because that's a 0. But let's do this. I got to do this. So v of t is same thing as, so velocity is the antiderivative of acceleration, which is 12t, right? So when I do it, plus 1 over 2, so velocity of t is equal to same thing as 6t squared plus c. But remember, your velocity is going to be equal to 2 when t is equal to 0, right? So I'm going to plug in, so your velocity is 2 when you plug in 0 squared. But as I said, if you plug in 0, this 2 is going to be c, right? As I said, that's what it is. But what you're trying to find is the position of the particle. And position is going to be 5 when t is equal to 0 again, because that's what question says. When t is equal to 0, velocity is 2, and position is 5. So let's do antiderivative one more time. So antiderivative of 6t squared plus 2, because now we know what c is. That is same thing as the position. And when you antiderive it, so plus 1 divided by 3. So it's going to be x of t is equal to 2t to the third power plus 2t plus c. And when t is equal to 0, position is 5. Again, that's going to be the c, but I will show you why. 5 is equal to 2. Although on actual test, I'm not going to even do this. I will just go move. But these two disappear, so you get 5 equals c like that. So your actual so this is going to be the answer. Just difference is instead of c, now you're going to plug in 5. Okay? So get the answer. Now let's try question number 15. So this is very easy. So question number 15 says you got this one, and question is asking which one is continuous, which one is differentiable. Simple. If f of x is equal to f of x, then it is continuous. Okay. Then it is continuous. And f prime of x is equal to f prime of x, then it is differentiable. Okay, so let's plug it in. Let's say if these two are equal to each other. So negative x squared plus 3 equals negative 10x plus 28. And we want to see if they are continuous, which means if we plug in 5, they should be equal to each other. So negative 5 squared plus 3 is equal to negative 10, 5 plus 28. Negative 5 squared is 25, so that's a negative 25. Negative 25 plus 3 is negative 22. Let's see if they are equal to negative 22. Negative 10 times 5 is negative 50 plus 28. And negative 50 plus 28 is going to be negative 22. So do you see negative 22 equals negative 22? Yep, so it is continuous. So f is continuous, f is continuous. So these two are not going to be the answer. It's going to be A or B. If you don't like this one, what you can do is you can move all this number to the other side and then factor it. And then see if you get 5. You can do that, but why would you want to do that? So let's do the derivative part. Now, if you derive it, so now what we're going to check is if they are equal to each other like that, okay? So if first derivative of this one is here negative 2x, and you're going to, first derivative of this one is going to negative 10. So what you're going to do is negative 2x should be equal to negative 10. Now let's plug in 5. So negative 2 of 5 equals, here I got nothing to plug in. Let's see. And negative 10 equals negative 10. Do you see they are also equal to each other? So that means they are also differentiable. So continuous and differentiable at x equals 5. So we got this. It's very simple. Now let's try question number 16.